So let's start with the question number 9. Function is given such that the mapping is from n to n, that is natural number, and the function f of n is given to be n plus 1 upon 2 if n is odd, and it will be taken n by 2 if n is even for all n belongings to natural numbers. Okay, because mapping is from n to n. So for the solution, let us take the example n is odd number 1, let us take it 1. So f of 1 will be equal to 1 plus 1 upon 2, this will give you as a 1. In case of 2, if you are taking here even values 2, then you have to take this function 2 upon 2 will give you 1. So f of 1 is equal to f of 2, we are getting is equal to 1, but this does not implies that 1 is equal to 2. With a simple example we have proved this, so therefore this is not 1 function. Clear? Then how to prove it on two functions? For this we have divided the question in two parts. First case is if n is odd. If you are taking the value of n is odd, so if it is odd, then let us suppose n is equal to 2r minus 1, the general form of the odd numbers. In junior classes also we used to suppose odd number in this form 2r minus 1, where r belongs to n, natural number only you have to take in place of r. Okay, so therefore f of n is equal to what? That is equal to n plus 1 upon 2. In the question it is given n plus 1. In place of n you have to replace 2r minus 1 plus 1 as it is upon 2. Okay. So ultimately after calculation you will get here r. So what we are getting here, f of n is equal to r, and that is equal to what? Y, because for onto we have to take it as a equal to y, and y is equal to f of n, and further f of n is equal to r, it implies y is equal to r. So that's why for every natural value, natural number, for every natural number of y there will be a natural number of r. Clear? So this will be onto function. Then case 2, if r is even number, let n is of the form 2r, right, general form, then put 2r in place of that the given function that is in the question, that is n by 2. So 2r upon 2, after cutting you will get here r, and further in for onto we have to suppose it as equal to y. So ultimately we are getting here also y is equal to r. So for every natural number there will be a value of natural number of r also, so that's why it will be a onto function. So now you can see at the back page we have done, it is not 1 function but it is onto function. So one condition is not satisfied, so therefore the function will not be bijective. Clear? After that come to your question number 10. So two sets are given to you, a real number minus 3. Okay, just exclude 3 from the real number. For b, exclude 1 from the real numbers, and f such that a is mapping to b. Then function, given function is f of x is equal to x minus 2 upon x minus 3. So we have to prove it as 1 function. So for that let us suppose f of x1 is equal to f of x2, as we have done in the previous questions. So fill the values of x1 and x2 in the given function, this one. So x1 minus 2 upon x1 minus 3, x2 minus 2 upon x2 minus 3. Cross multiply, do the cutting, whatever is possible. After cutting, simplification, in the last you will get here x1 is equal to x2. So that is the condition for 1 function. So that's why it is 1 function. For onto function you have to suppose again, let the given function is equal to y. Cross multiply and simplify and try to get x in the form of y. Now you can see the condition y, that is b, r minus 1, just include y, 1 from the y. So you cannot put y is equal to 1 here, otherwise it will be not defined. So whatever the value, real value of you will put for y, you will get the corresponding real value of x here. Okay, so written here, for all y belongs to b, there exists x which belongs to a. So therefore this will be a onto function also. So the given function is 1 as well as onto function, so that's why it will be a bijective function. Clear? So this is all about the exercise 1.2, the main questions we have done. You are left with two parts of question number 2, one question number 7 and other question number 11 and 12. So you have to try it yourself so that you can have genuine practice in case of functions. Okay, I hope you have understood all the questions properly. Otherwise, go through the video 2 times, 3 times. Okay, you will be able to understand all the questions. In the last, I would like to say thanks for watching the videos. Okay, see you next time with the next one, exercise 1.3. Goodbye.